Welcome to Intelligence Gateway.
System vulnerabilities 2. System vulnerabilities are weaknesses or flaws in computer systems, networks, or software that can be exploited by attackers. They can include software flaws, network weaknesses, operating system vulnerabilities, web application vulnerabilities, human errors, physical vulnerabilities, and misconfigurations. To address these vulnerabilities, it is essential to implement security best practices, regularly update software and systems, conduct security audits, and promote security awareness among users and administrators. In this lesson we'll learn about the different 1. Mobile device vulnerabilities. 2. Physical vulnerabilities. 3. Process vulnerabilities. 4. Cloud/IoT vulnerabilities. 1. Mobile device vulnerabilities. Mobile device vulnerabilities refer to weaknesses or flaws in smartphones, tablets, or other portable devices that can be exploited by malicious actors to gain unauthorized access, compromise data privacy, or disrupt the device's functionality. These vulnerabilities can arise from various factors, including operating system flaws, insecure applications, malware infections, unsecured wireless connections, physical theft or loss, and inadequate patching and updates. Attackers can exploit these vulnerabilities to steal sensitive information, inject malicious code, hijack communication channels, or remotely control the device. To mitigate mobile device vulnerabilities, users should regularly update their operating systems and applications, download apps from trusted sources, use strong authentication methods, avoid connecting to unsecured networks, and employ mobile security software for additional protection. 2. Physical vulnerabilities. Physical vulnerabilities refer to weaknesses in the physical infrastructure or security measures of a system or facility that can be exploited by attackers. These vulnerabilities can include inadequate access controls, lack of surveillance systems, weak locks, vulnerable storage facilities, or absence of environmental protection. Addressing physical vulnerabilities requires implementing strong physical access controls, surveillance systems, security policies, conducting regular assessments, and providing employee training. By addressing physical vulnerabilities, organizations can enhance the security of their premises and protect valuable assets. Process vulnerabilities. The process of identifying and addressing physical vulnerabilities involves a systematic approach to assess and mitigate risks associated with the physical infrastructure and security measures of an organization. Here are the key steps involved in the process. 1. Risk assessment. Conduct a comprehensive risk assessment to identify potential physical vulnerabilities and threats. This involves examining the physical premises, access control systems, surveillance systems, storage facilities, and other relevant aspects. 2. Vulnerability identification. Identify specific weaknesses or flaws within the physical infrastructure and security measures that could be exploited by attackers. This may include inadequate access controls, weak locks, lack of surveillance coverage, or vulnerable storage areas. 3. Prioritization. Prioritize identified vulnerabilities based on their potential impact and likelihood of exploitation. This helps in allocating resources effectively and addressing the most critical vulnerabilities first. 4. Mitigation planning. Develop a mitigation plan that outlines specific actions to address each identified vulnerability. This may include implementing stronger access controls, upgrading locks, enhancing surveillance systems, or improving physical security policies and procedures. 5. Implementation. Execute the mitigation plan by implementing the necessary physical security measures and improvements. This may involve installing new access control systems, upgrading locks, enhancing surveillance infrastructure, or revising security policies and procedures. 6. Testing and validation. Conduct testing and validation to ensure that the implemented physical security measures effectively address the identified vulnerabilities. This may involve conducting penetration tests, security audits, or simulations to verify the effectiveness of the improvements. 7. Ongoing monitoring and maintenance. regularly monitor and maintain the physical security measures to address new vulnerabilities that may arise or changes in the threat landscape. This includes performing periodic security assessments, conducting employee training on physical security best practices, and keeping up with industry standards and best practices. 8. Continuous improvement. Foster a culture of continuous improvement by regularly reviewing and updating physical security measures, policies, and procedures. Stay informed about emerging threats, technological advancements, and industry trends to proactively address potential vulnerabilities. By following a structured process to identify and address physical vulnerabilities, organizations can enhance the security of their physical assets, protect against unauthorized access or disruption, and mitigate the potential risks associated with physical security threats. 4. Cloud/IoT vulnerabilities. Cloud and Internet of Things, IoT, vulnerabilities refer to weaknesses or flaws in cloud computing infrastructure and IoT devices that can be exploited by attackers. Here is a precise description of each. Cloud vulnerabilities. Cloud vulnerabilities pertain to security risks associated with cloud computing environments. Some common cloud vulnerabilities include: 1. Inadequate authentication and access controls. Weak authentication mechanisms, misconfigured access controls, or improper user privilege management can allow unauthorized access to sensitive data or cloud resources. 2. Data breaches and leakage. Insufficient data encryption, insecure APIs, or misconfigured storage can result in data breaches or unintended exposure of sensitive information. 3. Insecure interfaces and APIs. Vulnerabilities in cloud service interfaces and APIs can be exploited to gain unauthorized access or perform malicious activities. 4. Shared technology vulnerabilities. Cloud environments often share underlying technologies, such as virtualization or containerization platforms, which can introduce vulnerabilities if not properly secured or isolated. 5. Data loss and service interruptions. Cloud service providers may experience service interruptions or data loss due to hardware failures, natural disasters, or cyber attacks, impacting the availability and integrity of data and services. IoT vulnerabilities. IoT vulnerabilities refer to weaknesses in Internet of Things devices, networks, or ecosystems. Common IoT vulnerabilities include: 1. Weak or default credentials. Many IoT devices are shipped with weak or default credentials that can be easily exploited by attackers to gain unauthorized access. 2. Lack of firmware updates and patch management. Manufacturers may not provide timely firmware updates or security patches, leaving devices vulnerable to known exploits and vulnerabilities. 3. Insecure communication protocols. IoT devices often rely on various communication protocols, such as Wi-Fi or Bluetooth, which can have security flaws that allow attackers to intercept or manipulate data transmissions. 4. Inadequate device authentication and authorization. Insufficient mechanisms for device authentication and authorization can lead to unauthorized control or compromise of IoT devices. 5. Lack of encryption and privacy safeguards. Weak or non-existent encryption mechanisms and privacy controls can expose sensitive data transmitted or stored by IoT devices. Mitigating cloud and IoT vulnerabilities. To mitigate cloud and IoT vulnerabilities, organizations should adopt the following best practices. Implement strong authentication mechanisms, access controls, and user privilege management for cloud services and IoT devices. Regularly update and patch cloud infrastructure, IoT firmware, and software to address known vulnerabilities. Apply encryption and secure communication protocols to protect data in transit and at rest. Conduct security assessments and audits of cloud environments and IoT devices to identify vulnerabilities and implement necessary controls. Establish incident response plans and procedures to effectively respond to and mitigate security incidents. Foster security awareness and education among employees and users regarding cloud and IoT security best practices. By implementing these measures, organizations can enhance the security of their cloud environments and IoT ecosystems, protecting data, ensuring privacy, and mitigating the risks associated with cloud and IoT vulnerabilities.
Thanks for watching. For more information, like, comment, and subscribe our channel.